what's up? Faizan here from Research Beast. On this channel, I share different tips and tricks for researchers, different motivational talks, and I also talk to experts about the research methods or anything related to research. So if you're interested,
All right. Welcome to the presentation and the discussion about structural model robustness assessment in using smart PLS or the PLS-SEM. And here I'm the Zaman Sharkar. I'm the faculty member of Sana University Business School at Sana University, Malaysia. So today our discussion will be about what is structural model robustness. Yeah. So I'm going to talk about a little bit about this one, and also what are the three or the major statistical techniques that it's actually they applied to check the model robustness in PLS-SEM. So let's talk about what is actually what is the purpose of using the PLS-SEM. Yeah? And if we actually look back our literature, and it is shown that PLS-SEM actually is a combination of the confirmatory and explanatory modeling technique. It's mainly a causal predictive the technique which allow the researcher actually they to identify and explain their theoretical model. And these techniques they have overcome the apparent dichotomy between the explanation. And many researchers or scholars might argue that PLS-SEM might not actually focus on the explanation. It may not be confirmatory or the explanatory model, but yes, it's still based on the objectives and the statistical techniques. PLS actually cover both explanatory as well as the predictive, the causal techniques. So based on that, actually, here comes the concept of statistical robustness. Because once we want to actually, explain our model, once we follow the explanatory in concept, so we need to actually make sure that our model is highly robust, meaning that there is a less error, less biasness in terms of explaining the key endogenous variable. So what actually statistical robustness define or that it indicates? So according to Taylor, the term robust or robustness refers to the strength of a statistical model test or the procedure according to specific conditions of the statistical analysis. So in PLS-SEM, we try to actually predict the key endogenous variable by in-sample prediction and the out-of-the-sample prediction. For example, with the indexes of the R square or the F square or even the PLS predicts. So that robustness actually will validate how much accurate that the model predictability is. It also in regards to explanatory capability, model robustness actually will tell us how much accurate the theoretical model is in terms of analyzing the or explaining the target population. Given this condition actually of a study are made, and models can be verified to be true through the use of mathematical proofs. So that is the main actually purpose of assessing the statistical robustness. Whereas the Avila Mednia, it's according to their suggestion and the definition that robust statistics can be described as a subfield of mathematical statistics that seek to account for the fact that statistical models are at best only good approximation of the reality. There are many criticisms that the actually inferential statistics, we actually collect data based on a small sample, and we are trying to actually predict the entire population and the behavior of the entire population. So that robustness actually will give us it's a very good approximation of this, the findings. In Sarsted and here et al. Actually, they suggested that in regards to robustness test in a structural model, there are the four criteria or the four options that a researcher can actually think about. One is adding or removing variables or moderation. So mostly we do, but sometimes we actually beforehand we actually think about what will be our moderation or something like that. And also modeling non-linear relationships, and the major assumption of the PLS-SEM or the structure equation and modeling is that we assume that the relationship is highly linear, meaning that the slope and the beta coefficient will be very much the linear to depends on the variable independent and the dependent variable. But in reality, it might not be. So if the result is non-linear, the assumption of the result that we get from PLS-SEM might not be, the robust. There might be some concern. Then another technique is assessing endogeneity. That one is another important issue. But if, let's say, some research actually wants to follow the explanatory modeling technique, they have to ensure that the end variable or the final dependent variable they actually chosen, it has that endogeneity characteristics. Other than, if not, then there will be highly question whether our model is rightly conceptualized or the wrong way to conceptualize. And the last option that we have, which is unobserved heterogeneity, in most cases that we actually do not think beforehand what will be the moderating variable. Sometimes after collecting data, or the respondents that we choose, their response might be, the group that we actually didn't notice before. So these are the four actually criteria that used to assess the robustness. So in this today in lecture, I'm going to actually cover these three aspects, because how to do moderating and a moderation analysis, all of us actually is pretty much familiar with this one. To show, to actually exhibit and demonstrate this hands-on, or the analysis. So I'll be actually we will be analyzing this result or the data based on the corporate reputation model, which is available in the PLS-SEM book, or many reference. Actually, we can get it. The user also, they can actually download the data and everything. Even in the smart PLS software, it is also, it's given as a for the practice that any user actually can do that. So I will be actually doing all this analysis based on this corporate reputation model, and the user, they can actually download this model, they can download the data, and they can also do their practice as well. So first one is about assessment of non-linearity, right? So what is non-linearity, and how actually non-linearity can actually influence or the result that we got from PLS-SEM? When the relationship between two constructs is non-linear, the size of the effect between two constructs not only depends on the magnitudes, but also it's of the changes in the exogenous construct, but also in its value. So if we think about our relationship is linear, and we assume that relationship is linear, but our data is actually telling a different story. So the beta coefficient we'll have in this, the slope, it will not be actually the reliable or the valid one, because with the passes of the time, or the progress of or the increasing of the dependent variable on the independent variable, the beta coefficient will actually change. So that can be the issue about the non-linearity. So to looking at that, how what is the non-linearity in the PLS-SEM result, if we actually see that non-linearity is not present into the PLS-SEM result, that actually we can assume that our result is the reliable and the valid in regards to the beta coefficient. So how actually we can do the non-linearity test using PLS-SEM? There are actually two ways we can do. One is using the smart PLS, and which is pretty much similar to moderation analysis. We actually do using the quadric effect, and so it's much more easier. So let's go back to the smart PLS software, and let's do this test using the the smart PLS. All right, so in the smart PLS software, this one is actually corporate reputation model. If you look back here, and we'll be focusing on the simple model one. In this model, the theoretical assumption is that the competencies like and the customer satisfaction is the predictor of the customer loyalty. The customer actually feel loyal if the organization is competent and customer is highly satisfied, as well as they have the they actually like the organization. So how we can actually do that? We need to actually create the quadric effect of each and every relationship directed to this dependent variable. So it means that there are three predictor of customer loyalty. So we are going to create three quadric effect one by one, and we'll see whether this quadric effect is significant or not significant. So it's pretty much straightforward. So let's create the quadric effect here. Right button click and add quadric effect. And what should be our independent variable? So we need to actually do one by one. So let's select the competency first. And among this calculation method, the mostly orthogonalization may be preferred one or the two states, but it depends on the research objectives. If we actually choose the orthogonalization, it means that we are actually trying to minimize the error of the other, effect of the other independent variable. For the two stage, actually, if our main objective is to focus on the significance, so maybe we can choose the two stages. So for this case, like I'm going to choose the orthogonalization, and let's other option keep as it is, and let's create this one. We can actually name it as the comp, which is competency. Okay, that should be the quadric effect. So to test the significance, we need to do the bootstrapping, and it is normal procedure like others. We have to choose the 5,000 bootstrapping. Then we need to derive the result, and the type test should be the two-tailed, whether because we need to see whether it's a significant or not significant. We're not caring about whether the result will be positive or the negative. So let's click on the start calculation. So I just created one, but remember that we need to actually create for each endogenous variable directed, exogenous variable directed to the endogenous variable. Yeah. So yeah, it's almost done. All right. So just to quickly see the results, if you actually see the t-value, this is a t-value, so it's 1.139, meaning that it's not significant. The assumption is that the linearity is present is the null hypothesis. So if we actually if it is significant, meaning that the non-linearity is present. Yeah. Okay, yeah, this one. So it's not actually significant. So we can assume that the non-linearity is not present. Yeah, meaning that the relationship is linear. So this is how actually we should test for all other customer satisfaction and the for the like. So I'm just going to go for the another option because that will be the pretty much similar steps to see whether non-linearity is present or not. Yeah. So I'm going to actually go for another test to see whether non-linearity is present or not. Yeah. So for the smart PLS, this is how we do. But remember that in smart PLS, we'll get the non-linearity test by each and every relationship, not as a whole model, not as a whole model. So for the whole model, we need to actually do another test, which is called the Ramsey's reset test. Yeah, so Ramsey's reset test will actually look at the linearity or non-linearity for overall model. So in this corporate reputation model, let me go back to this model. So here there are two regression model. It's actually over here. For customer loyalty is one regression model which has 3 predictor. For the customer satisfaction, there are 2 predictor. So we need to test whether this statistical model is linear or the non-linear. All right. So to test this Ramsey, we need to actually go to the SPSS, and we need to have the data as well. And this data is available in Smart PLS website. So you can easily download this data, or even from here you can actually download the data and you can paste to the create in the SPSS file. So this is what file I downloaded. So from here we need to actually create. We need to have the latent variable score for all these 4 variables. Yeah, and that latent variable score we can extract from the Smart PLS. And I think all of us are aware about this process, how to extract, and we can create this one. So from this one, I'm going to do the Ramsey's reset test for let's say for customer loyalty. Let's do that. So to do the Ramsey's reset test in SPSS, we need to first create the the predicted unstandardized predicted value. And to create the unstandardized predicted value, we need to analyze using the regression. We need to go for analyze regression and linear regression. We need to choose. From that side, we need to select which regression model actually we're going to check for the non-linearity. So let's say we're going to check for the customer loyalty. So let's select customer loyalty as a dependent variable. And we have 3 independent variable for customer loyalty. let's drag it into the independent variable, and among this all the statistics, we just need to actually click on the save to save the unstandardized predicted value. This one only, so no need to actually check other the option. So let's do the continue. So once we click continue and once I click OK, the unstandardized predicted value will be saved into the our spaces file. Yeah. So this is what unstandardized the predicted value. So this unstandardized predicted value we need to actually compute. We need to transform and compute for square as well as the cube, the cube value. So to transform or to create this square or the cube value, we need to go for the transform and compute variable, and we need to actually declare our target variable. Yeah, so that target variable will be first for the predicted is, let's say, square. So pred, let's say I am giving the name pred2. That will be the new target variable, and the numeric expression will be this unstandardized predicted value, which is pred1. Let me change this variable. Okay, so predicted one, it should be squared. Yeah, so this one is the double star, and we need to do the 2. So that will be the predicted 2. Press OK. Yeah, and it's already been calculated, and we can actually see the value of this. Yeah, this column is already valid. So let me increase the decimal point over here. All right, so we need to create another value which is predicted cube. Yeah, so we need to actually follow the same procedure just to make it as a cube. Click on transform, compute variable. There will be another target variable which is 3, I mean cube value, and that expression it should be square by a cube by 3. Yeah, so let's click on OK. All right, so now already this value being created. Let's convert to 5 decimal point just to make it consistent. All right, so now we're going to actually include this these two value with our regression model that we are actually targeting to see whether the overall model, whether it's a linear or non-linear. Remember that the statistical assumption for this one, actually the null hypothesis is that linearity is present. Null hypothesis is linearity is present. So if the statistical significance or the p-value is less than 0.05, meaning that we are actually the rejecting whether null hypothesis, that means non-linearity will be present. So we may expect that our value will be a little bit higher than 0.05 if we really want to see our model is linear. All right, so let's check for this one. We need to go for the regression analysis. Regression, we need to check on the linear. Then with this normal setup, customer dependent variable is our customer, loyalty independent variable or the competency, customer satisfaction, and the like. And we need to click on the next and need to include all this, these two, predicted and the value, which we actually created here. These are the two predicted square and the cube value we need to include in as an independent variable. And in regards to statistics, we need to no need to change anything over here. Just continue. Option, we need to actually select on the, yeah, nothing is needed over here. Option is fine, nothing. Style, yeah, and we need to actually click on the R squared change over here. Yeah, so that one we need to actually click on because we need to see whether there is a significance level of R squared change in these two model or not. Yeah. So click on continue and let's click on the OK. So with these results, yeah, I have already got the results. So there are two model actually. For one is without this predicted value, which is created through the latent variable, and the second model actually with that the quadratic effect or the square effect. So we are going to see whether second model is significant or not significant. So that result we can actually read from this model summary, and we need to see on the second model, because second model has this two predicted value. And if you look at this f square change, look at that, it's less than 0.05. So meaning that we are actually rejecting the null hypothesis, which is the model is linear. That means the customer loyalty model is actually non-linear. There are some relationship which is non-linear. Looking at this smart PLS results, from there, this result is not significant. That means competency, it's not a linear relationship, yet it might have the non-linear effect. Over the point, there may be different beta value. But if we actually assume it's a linear relationship, this beta coefficient is very low. Yeah. So it is also indication that the customer loyalty actually this model is not linear. So maybe if we check all other two independent variable, will be pretty much sure which path actually has linear or the non-linear. So right now the competence is a non-linear relationship. This is, we actually got it from there. That's how actually we do to check the non-linearity as a separate model. So this same procedure we can repeat for the customer satisfaction, because customer satisfaction has two independent variable. So we just need to create an standardized predicted value for the two independent variable, and later then we can do the quadratic term, and this is the same way that we can actually check, and we can actually decide whether the model is linear or the non-linear. All right, so this is how actually Ramsey's reset test has been done. So how to actually prepare the report? So any paper, standard paper, like we can follow. One of the paper is Search 2029. They actually showed all the demonstration how to do non-linearity test, unobserved heterogeneity, and the endogeneity. So maybe we can follow the same style to report the findings and in terms of the explanation. All right, our second test is assessment of unobserved heterogeneity. So the way actually we add moderation is to observe heterogeneity and unobserved heterogeneity. After collecting the data, we actually are unaware about whether there will be any moderating effect or there will be no moderating effect. So from the non-linearity, maybe we may assume that some variable might be influencing, or maybe have has interaction effect for which actually result is non-linear. Something might be there, so we actually don't know. So that heterogeneity, unobserved heterogeneity test also will provide us that indication how much, whether the moderation or the unobserved effect will be present or not. So what is unobserved heterogeneity? It is when occurs subgroup of data exist, which actually researchers are not aware beforehand, and which entails substantially different model estimates. So with that example, if we actually have the one model, look at that, perceived useful has an effect on intention only 40%. But this, if we actually make it two groups, this effect is substantially different. Here is 70% effect, and here is only 10% effect, and totally reverse. So meaning that this unobserved heterogeneity will also give us very strong indication that whether our model has a subgroup or doesn't have any groups. So how to do that? This one we need to use the smart PLS, and we have one option which is PHYMIX. We actually do this unobserved heterogeneity using the finite mixture PLS. Yeah. So there are few criteria that we need to remember once we run the PHYMIX segmentation. Number one, how many segments that we are going to actually decide, because we need to manually, as a researcher, they have to decide of what should be the potential number of segments that I'm going to think about. So that potential segment is decided based on the small sample size. And that small sample size can be consider the G power would be one of the issue, or maybe if we think about Koch and Hada's inverse root square of the gamma coefficient, that also can be, but it's based on the researcher to decide. So let's say I have 300 sample size, and if I assume that my minimum requirements of sample size for my theoretical model is 100, so maybe I have to think about three. Number of segments will be three. So based on that three, I need to actually continue and repeat the analysis three times. So what are the actually the determinants or the indexes that we need to look at? On the output table, we need to look at the archaica, the information criteria three, and the consistency, CIC. So we need to actually see whether AIC3 and the CIC has the same or consistent result, or AIC3 or the BIC has just consistent, the consistent results or not. Either way, we can actually look at, and this is another criteria that the en value, it must be at least 0.50. Here is one of the suggestion that search is given, that for the Phoenix PLS, the AIC4 and BIC actually generally perform pretty well. This is one of the criteria. So if you go back, these are the options that actually perform pretty well, AIC4 and the BIC. So either way, we can decide whether any of the result has consistent. We can actually decide how many segments will be. Another suggestion is that to decide, normally the number of segments, potential segments, should be higher than the MDL5 or lower than AIC. So these are the general the criteria we decide. This is one of the examples, which is the paper I was talking about, which is Sastre et al. 2019. They demonstrate all this analysis, and they reported. So from this table, if you look at if you see, these are the criteria fit index table, and they actually decided that their potential segment will be 5, and they run 5 times, and this is how actually the result. We need to look at the minimum value of each and every row. For example, under the AIC, minimum value actually in segment 5. For the AIC3, if we see that minimum value is also under 5 segments. But in AIC4, based on AIC4, look at that. The minimum the value is on segment 2. For BIC is also segment 2. So the criteria that we actually set, the value should be either AIC3 and CAIC, or AIC4 or the BAIC. Yeah. So let's say if these two are the same, meaning that with this model, the model they had, actually there should be potential 2 segments, and also the en value is above 0.50, yeah, which is entropy statistics. So however, the final criteria that I've been talking about, that the number of potential segments should be lower than AIC or higher than this MDL5. So MDL5 has also lower value in segment 2. That means the potential segment should be higher than 2, lower than 5. So with that statistics, they concluded that unobserved heterogeneity is not a concern, because this result actually is not consistent. Also, if you look at this number of segment, look at that. If we consider, the model has 2 segments, so for the second segments, only 20% sample out of this total sample actually accounted for in segment 2. So we need to also check out this, whether this 20% actually fulfill the criteria of minimum sample size or not. All right. So this is how we actually decide. So let's go back to the hands-on, how to do the analysis. So I'm not going to actually analyze 5 times, just to show how to do the analysis. Then in regards to the report preparation, so you can follow this style. So we need to go back to our smart PLS. So this model, we're going to actually look at how many potential segments should be. Let me delete this one. Okay, so with that sample size 344, I check with the G power that the minimum sample size required for this theoretical model is actually around about 80. So if we divide 344 by 80, there will be, I think, 6 segment, right? Probably it's around 6 segment will be there. 80 five, right? Yeah, that will be around 5 segment. So that means to calculate the phi mix, we need to go for the phi mix. We need to actually run 5 times for, let's say, for single segments. What should be the fit index? We need to derive, after I start click on the start calculation, the result we will get, that will be for the number 1 segment. Then the second time we need to select for the 2 segment. Again we need to run the calculation. For the third time we need to actually calculate. So let me go for the 5 times, since we assume that based on the minimum sample size the potential segment could be 5. So let's choose the 5 and other option remain unchanged. Let's start calculation.
Munir, I have a question. So the first one you did was non-linearity, right?
Right.
And then you said that the model shows that it is non-linear. There is some
Exactly.
non-linearity here. Then
Exactly.
you move to unobserved heterogeneity. So let's say if in the first step you realize that your model is linear, right? It's linear. So do you still have to go to check unobserved heterogeneity, or no need for that then?
Yes, we need to actually check for unobserved heterogeneity, because for the non-linearity, we check path by path as well as model separately. Do you remember for the Ramsey, we need to actually run one statistical model, but in unobserved heterogeneity, it's giving us the overall theoretical model.
Okay.
Yeah.
Okay.
So
Okay,
yeah.
so one other thing I want to ask you is that when we do the Ramsey reset test, right? So normally, let's say if you have a structural model, in the model you have several regression equations, right? Just like in this one, we have 2 regression equations.
Right.
So I assume that you have to do the reset test twice, right? One is for equation 1, one is for equation 2.
Right.
Then it's possible that for equation 1 you get a positive result, means that there is some sort of non-linearity, and then the other one shows that there's no non-linearity. Then in that situation, what do we assume? Because then, like, the overall model, what does that show then?
Yeah. So yes, it is pretty much the possible. Even if I actually didn't do the non-linearity Ramsey's for the the satisfaction. So it is much can be expected. And in that case we need to actually define which model has the non-linearity and what should be the potential reason. Yeah. So that is actually the another steps to explore further. What is the result, or even which path has the non-linearity. That on we can look at the smart PLS results, and we can think about what should be the potential variable in this relationship can be. We
Okay,
can
thank you,
explore
thank
further
you.
on that. Yeah.
Thank
So yeah,
you.
so I already got this unobserved heterogeneity results. So to check the results, we need to check for the fit indexes. Yeah, this fit indexes. So all this information are actually here. So if we actually copy that one, this information for the 5 segments. Yeah. So if I actually go back to this slide, let's say the Sustain et al. Their result has 5 segments. This last column value actually representing the output of this this is what PLS. So we need to actually copy and paste to Excel file. Then we need to actually extract the segment size under final results, which is the segment size. So this is a segment size. Look at that. Let's say the fit index is indicating that segment 5 potential sample size should be the segment 5. Let's say, for example, but look at the segment size. It's 0.05, 0.06%. So out of this 300 sample, 6% will be only how many? Like it's very small. So it is not actually realistic. So there are many ways actually you can justify whether the overall model has unobserved heterogeneity or not unobserved heterogeneity. All right. So this process we need to run, extract the results, and prepare the Excel, based on the Excel file, and again run for the, let's say, for segment 4, then segment 3, segment 2, segment 1. So this is how we need to actually proceed. Let me just go one by one. if I actually extract this one, let's create the information criteria. Let's copy this result fit index results. Let's paste here first. Okay. This one is mainly information criteria. These are for the 5 segments. Yeah. So for the 4 segments, we need to paste the value here for 3 segments. So we can actually rearrange 1, 2, 3, 4, 5. We can go accordingly, no problem. So then we can actually decide what should be the potential segment. And remember that the value that we need to target as the lower, the information criteria or lower value. Out of these overall row values, we need to actually target on the minimum values of among all these values. Then we can actually decide. Right. Okay. Let's run for the 4 segments. Let's see what happens. Start calculation. That means we need to actually run 5 times, and each and every single times we need to extract the result values, and we need to actually prepare the results.
Okay, so Munir, in this step, right, it's not necessary to have 5 segments every time, right? It would depend on what is your overall sample size, and then depending on that, you would decide how many segments, yes?
Exactly. So it's the way we decide will be based on minimum sample size required for for my theoretical model. So we can actually decide based on that. Even yeah, please.
Yeah, so the question is that sometimes you have a data set with really relatively smaller sample size, right? Like maybe if somebody is doing research on managers or a CEO or something, then how do you do, I mean, how do you deal with a situation like that where your sample is already pretty small?
So assume that if the minimal sample size requirement doesn't fulfill, and if indicates that it will be potential 1 segment, so actually there is no reason to go for the unobserved heterogeneity.
Yeah. Okay, perfect. All right. Yeah, so it makes sense, right? Then your sample is so small that it probably doesn't even have unobserved heterogeneity.
Exactly.
All right.
Exactly.
So Munir, while it's taking some time, right? So you helped us understand the reset, right? The Ramses test, but you helped us do it through SPSS. The current some of the stuff that I saw on internet, and there was a PowerPoint slide or deck also by somebody. They use R to do that, right? So the method that you show doesn't require R, right? It doesn't require you to run anything in R. Yes.
For the endogenity, we need R. Yeah. For
So
endogenity,
okay.
we must go for the R. We cannot actually do using the SPSS.
Okay.
We can do with the stata, but for the the Gaussian coupler, the one with the R will be Okay. So this result is for the 4 segments. Just let's copy information and arrange here. We just need that value here. And so this is how we just copy and prepare the table, then we can actually decide. So let's say we have only 2 segments. So which value we should actually highlight between these 2 value? This one is the lower, right? Yeah, minimum value. So let's make it bold. Here, this one is the lower. Just highlight all these, the minimum value. All right. So since only we have got the four segment results, we don't have 3, 2, and maybe the minimum value will be different. So based on that, we can decide the potential number of segments. The entropy value, we need to look at whether it's a 0.5 or not. Yeah. So we can do that and repeat and prepare the result. All right, let's go back to our slide. So this is how actually we do that. Remember that after all these, we need to see whether the potential number of segment again, I'm repeating, the potential number of segments should be lower than AIC value, or indicated value, I mean the lower value, and should be higher than the MDL5. Okay, MDL5 meaning that the minimum descriptive length with 5 factor or factor 5. So if that, and this it actually gives a consistent result between AIC4 and BIC, or AIC3 with BIC, or AIC with the CAIC. So that minimum value should be consistent with each other. And if not, then we can decide the model doesn't have any unobserved heterogeneity. In this research, actually, they concluded that this model doesn't have unobserved heterogeneity, although AIC for the BIC is a consistent. But with that MDL5, because it should be higher than the required number of samples should be either 3 or 4, but it's indicating 2, meaning that there is no potential unobserved heterogeneity. So this is how we decide. All right, so our next one is endogeneity. It has very long interpretation and understanding with that we need to actually develop, and I'm going to actually repeat and explain the paper which is published in 2018. And in this paper, Halt et al, they showed how to do the the unobserved heterogeneity, or the procedure they have, and they provided all this data as well as the R code in their websites. I actually downloaded all this information from the website. The slide, everything is there. So I'm just explaining how to do the endogeneity in PLS-SEM. Okay, so what is an endogeneity problem? Endogeneity can have various routes, and such as measurement error or simultaneous causality, common method variance, or unobserved heterogeneity. There are many reasons that it can be. And sometimes we may ignore the prominent variable into the model. It can be also another reason. So some omitted variable can be there, and with that omitting such variable induces a correlation between the corresponding independent variable and the error of dependent variable. The major concept is that since we are ignoring some of the major variable, the exogenous variables may have influence on the relationship or the correlation with the error term of dependent variable. If this happens, it will indicate that there is an endogeneity problem. The variable that we assume is a final dependent variable might not be. Maybe some other variable could be endogenous. And that is the independent variables. Then not only explain the dependent variable, but also error in the model if it is a correlation with that. With this figure, look at that. The correlation between the exogenous variable x2 and the error term of dependent variable, if it is 0, meaning that there is no correlation. So this relationship doesn't have the endogeneity problem. But with this x1 exogenous variable and this one, the correlation is not 0. It can be plus or minus, whatever, meaning that since the correlation is present, that means this relationship has endogeneity problem. Maybe y is not endogeneity for x1, something else. So this is the main concept actually. The endogeneity assessment tell us. That's why in regards to explanatory model, if you want to actually focus more on explanation of this model, endogeneity tests must be there. Other than we cannot conclude that our model is highly robust. Well, there are many approaches to check for the endogeneity. Currently, we are going to go for this Gaussian coupler. There are some other techniques as well as adding the control variable or the instrumental variable, and these are the statistical tools that we can do actually. For the Gaussian coupler, we are going to use the R software to see whether the endogeneity is present or not. Okay, and actually before going for the test, there are some checklists whether we actually need to go for the endogeneity test or not. Yeah. So this information is available in the paper, so I'm not going to repeat. Maybe we can actually go for that. So this, I'm going to highlight this one. If our primary objective is the explanation, then from that concept, maybe we can think about the endogeneity. If our main focus is the prediction, So maybe we can end up our analysis with PLS predict. No need to actually go for the endogeneity, or even the dependent variable that we choose in our model. If it is let's say used several times and the result is consistent all over the previous research, then also maybe we could argue that we don't need to actually check for the endogeneity because it's already been established. Yeah. So this is how we can actually decide. So there are some checklists we can go by and we can decide. Uh, the data and the the slide, everything that I downloaded from here, all the details are given here. So I'm just going for the hands-on straight away. So the few things actually we need to decide before going for the R or checking for the endogeneity. One is data preparation is one of the first step, because the normal Excel file or the CSV file data that we actually do, this CSV data file is a little bit different. So we need to actually prepare the data file, and we need to estimate the PLS path model. Yes, how many path model or how many Gaussian coupler model that we need to actually decide. That one we need to actually decide beforehand. And the second step, we need to check for the our code requirements, and as well as check in our analysis result. There are one requirement is that check for the normality. Yeah. In the endogeneity, the endogenous variable should not be normally distributed. It should be not normal. That's why we need to actually check for that. If we see the potential endogenous variable is normal, then we cannot actually proceed for the endogeneity test. No need to go for that. If we see that potential endogenous variable is not normally distributed, then we can proceed further. And then the third step, we can go for the model analysis. With this corporate reputation model, let me think about decide how many Gaussian coupler model will be there out of this relationship, because customer loyalty is already endogenous variable. We need to check whether the error term over here is actually has correlation with all these three and exogenous variable or not. So to check that, how many module will be there? For example, for competency, there will be one coupler. For customer satisfaction, there will be another coupler. For like, there will be another coupler. Then with these two, there can be another coupler. With these two, there can be another coupler. Yeah. And with these two, there will be another 6. There will be another, the Gaussian coupler model, and all these 3, there will be another model. So that means with these only 3 exogenous variable, there could be possible 7 Gaussian coupler model that we need to check for. And these 3 variable assume that any of these 3 variable can be endogenous. So the first step is that we need to generate data, the data that we can generate using latent variable score. If you actually click on the latent variable here, we will see that result. But we should click on the R format to copy the Excel, this value. You just click on the R format and paste to your Excel. So since I copied this all this data, extracted data from the website, let me show you the file. Yeah, this one is the data that I extracted from this website. So the data should be separated by semicolon. This is how it will look like. Normally, normal CSV data like this, actually it's not readable in our software. So they have a special requirement that we need to actually prepare. All right, so let me close this one. Okay, so this is the CSV file that I showed you. Then first one is we need to check for the requirements, whether the potential endogenous variable is normal or not normally distributed. They actually given that code in a file. Let me go for this file. This is the file. This CR coupler. This is coupler, and this is for the normality test. Let's open this one. So I'm just going to follow this step, and using the R, I'm going to show you how to actually calculate. So you need to install the R software if you do not have in your PC. So I already installed here. So first step, you need to check for the normality. So to check for the normality, the first step actually we need to actually set our directory. So how to set the directory? We need to actually declare where our analysis will be stored. Yeah, so which folder or where in our lab in your PC that it will be stored. So let me copy this one here and paste to the R. Since I'm going to actually store my result under practice over here, this folder actually I'm going to actually see since I have the data here. So I'm going to copy this address and paste it in the R, because I need to actually change this one. Yeah, and look at that, this sign is slash rather than this one. So I need to change all this into slash, double bracket, then I need to change all this to slash. Because in R, anything a little bit change, actually this model or the program will not run actually. Yeah, so I already declared this one. Let's click enter. So if this is happens, meaning that actually this setted code is actually perfect. Yeah, it's correctly specified here. So once I declare the directory, the next step is install the KS correct. KS correct is a conglomerate is mean of test. So if this package is not installed into the R, we need to actually install first. So to install first, you have to write install.package. This is the code that you need to actually write here in this R. So in that case, I have already installed, so I don't need to actually write this code. I can actually straight away go to this one. I need to call that I'm going to test for the normality using KS correct test. So I need to call on this one in R. Then click enter. Yeah, so it's actually ready to analyze the data for normality. Okay. All right. So the first one is we need to read the data. Which data that we are going to actually read? Remember that that should be exactly the the name of the data folder. Let me show you. In the folder, look at that. I'm actually referring this one. So the data folder name is CRP underscore dataset underscore STD. So that name should be as it is in here. CRP under this, the double bracket. That name should be the same as the data we actually name it. So once we actually do that, if there is another option it's asking for, it means that they successfully read the data as well. So now we're going to actually read our variable. There are three potential endogenous variable that we're going to actually read. So we need to copy and paste to the R, click enter. So it's mean that everything is good. Now check for one by one. For the variable like, we are going to check whether this distribution is normal or not normal. Click right and enter. So it will quickly give us the result. Okay, all right. So this is the result p-value. You can copy and paste to somewhere else. And this p-value should be higher than 0.05. The assumption is that the null hypothesis data is normal. So if the p-value is less than 0.05, we are actually rejecting the null hypothesis. So the value, since we want to prove that the distribution should be not normal, so we are expecting the value should be less than 0.05. So here it is very far less than 0.05. It's 0.00000 something. It's very few. So meaning that this like variable or competence variable is not normally distributed. So this criteria is already appropriate to proceed for Gaussian couple analysis. So I'm not going to actually repeat all these three. We can go one by one, and based on this statistics, all these three variables actually not normally distributed. All right. So next, go to our couple analysis.
Munir, excuse me. So these here on this step, if somebody has a more complicated model, then this will include all the endogenous variables, right? All the variables that are getting an impact from independent variable. Yes.
Exactly. Yes. Let's say since this model is pretty much what is that? It's pretty much simple, right? Only it has only 7, the Kaplan model. Some theoretical model might be, let's say, 5 or 6 variable. So there will be, I don't know, like maybe 15, 16 Kaplan model can be out of there. Yeah. So for each and every Kaplan, we need to check whether the Gaussian Kaplan is significant or not significant. Okay. So let's go for the Kaplan analysis now. Let's open this Kaplan code. Okay, so the first thing is that we need to set the directory, but we already did during our normality test. So we don't need to actually set the directory anymore. The second one, for the coupler analysis, we need to have the library car package, car indicating something related to the coupler. So if someone doesn't have the car package, so they need to actually install this car package. Then once it is available into the R or into someone's computer, just the step that they need to look for, call for this R coupler. So I have already in my R, so I don't need to actually install anymore. So let's call the directory. It will take a little bit, few seconds to keep it ready. Yeah. All right, so it means that this package is ready. Now the second step, actually we need to create the coupler. So to create the coupler, there is a formula that which already R code is given by this author. So I'm just going to copy and paste this into this R code using this bracket as well. Right. So yes, it's already created the how to create the coupler. They already did that. Then next, we need to set the bootstrap significance. This one also need to set up. Copy and paste in R. It's already set up. So these two are important because the first one is for the creating the coupler. Second one is because we're going to see the bootstrap significance, not the normal probability distribution, right? Because our distribution is not normally distributed. So that's why we need to create the bootstrapping significance. Then we need to again read the data. Let's read the data for this coupler analysis. Okay, so now this one is for to make the software read about our variable. There are 4 variables into our corporate reputation model. Customer loyalty is the dependent. So later on, we're going to actually set the standard model, the next phase. But before that, we need to actually read this variable to the software. So these are the 4 variables that we're going to analyze. Then we're going to actually estimate the standard model. Standard model is customer loyalty is a dependent variable, like competency and customer satisfaction is the independent variable. So let's copy, paste it here, enter. Yeah, so they already calculated the standard model. These are the P distribution value. So based on that, we can actually see, or even the overall model which is significant or not significant. But before that, we need to go for the bootstrapping. So later we'll go for the bootstrapping. So now for we already declare the variable, and also we actually set our standard model. So now we're going to actually create the coupler for each potential endogenous variable. So these are the 3 potential endogenous variable that we need to create the coupler. So let's enter. They already created. Now we need to set the bootstrap. It's here. It's 10,000 is by default into the R, or in this Gaussian coupler. Boot is it's the bootstrapping subsample. Now it's let's go for the first model. Yeah, the first model. Let's check for the coupler for competency. Yeah, because there are, we estimated that seven coupler model will be there. So they started with the competency, and they're going to calculate the coupler for the competency. That will be result 1. So this is the result, but we are going to actually do the bootstrap. For the bootstrap, this is the copy. Yeah. So it's calculating all the subsample bootstrapping. Now, okay. Yeah, so this is another information that we need to look at. This 3 and 1 over here, it's indicating something important, because this 3 and 1, especially this 1, will be changed, and it will be associated with how many coupler we have in our current analysis model. For example, in this model, we have only one coupler, right? So 3 indicating the number of independent variable, and 1 indicating the number of coupler. So we have 1 coupler. Yeah, so finally, we actually got the value, the results, significance results of the coupler. So these are the competency as an separate independent variable, like as a separate independent variable, and customer satisfaction separate independent variable. And this is the coupler, which is very higher than 0.05. So this coupler is not significant. So for this competency, we can see competency as an individual. It's not a potential endogenous variable. So this process should continue for 7 model, meaning that first we check for the competency, then we need to check for the like, we need to check for the customer satisfaction, then we need to check for the competency and like together, then competency and customer satisfaction together, then like and customer satisfaction together, and finally competency, like and customer satisfaction, all 3 together. So 7 times we need to run this analysis, and all this actually informations are here. So once you actually change the data, look at that. For this one is a for they're checking for the like coupler for the like, and since number of coupler is 1, it's already 1. But how about once they included 2 coupler? For example, result number 4. Yeah, look at that. There are 2 coupler here, so the value is already changed. It's 2. 3 independent variables, 2 dependent, 2 coupler. And for the final 7th model that we estimated, there will be 3 coupler together. This is 3. Right. Okay. So so I'm not going to actually repeat all this. Just anyone often can actually copy and paste, and they can adjust based on the theoretical model, and they can actually end all this analysis. So now what is important actually to look at the results, and how do we decide whether potential endogeneity is present or not. So normally we check for this bootstrapping significance results and this probability of the T after bootstrapping of each and every coupler, and we need to actually focus on here this one, as well as if let's say this coupler is significant, Then we need to check the beta coefficient as a normal model as well as with the coupler model. So let's go back to the slide. We already actually check all this. We already actually followed all this, so we can actually go by one. So I'm going to go at the end result. They actually summarize the report. Okay, so these are the output that we actually see. Okay, so this is the table that we need to prepare. Look at that. Initially, we check a couple for individual model. This is an original model for competency, for like, and for customer satisfaction separately. And we need to see on this, the p-value, whether competency coupler is significant or not significant. This is the beta coefficient and this is the significance level. So competency is not actually, the coupler is not significant. How about the like? Look at that. Like is also insignificant. It's not a problem. But how about the customer satisfaction? If someone actually assume their significance level is 10%, with that significance level, customer satisfaction has some potential endogeneity. Maybe customer satisfaction can be endogenous variable. If someone actually assume, the 10% significance level, so since it is less than 10%, so maybe potential significance, customer satisfaction can be a potentially endogenous variable. How about the dual model? For example, between like and competency. For the like and competency, p-value is far above than 0.05, so no problem with that. This one, like and the customer satisfaction. Again, at the 10% significance level, customer satisfaction has some problem. For over here, as you look at that, for a couple of between competency and the customer satisfaction has problem. Even 5% significance level, customer satisfaction has some endogeneity. Over all these three as well, seventh model, whether we included all these three coupler, also here look at that. It is also the significance. So with these 7 results, we can assume that maybe customer satisfaction might have some endogeneity. The traditional or the corporate reputation model, although they reported customer loyalty is an endogenous variable, but maybe customer satisfaction can be. And also there might some literature support that many researchers actually see, they actually plotted customer satisfaction as the end variable rather than the antecedents of customer loyalty. So theoretically it is also suggested. So this is how actually we derive the results and we can decide. Now how should we actually support these findings? That will be based on the previous literature, arguments, explanation, and everything. Yeah. So this is how we do the endogeneity using the Gaussian coupler, and we actually decide. I think that's all about these 3 methods, and this is how actually we do the the analysis.
Thank you very much, Munir. It was very detailed, and I think it's pretty good that you covered it hands-on as well, so it's going to help a lot of people. And you also answered some questions in the middle.
Yes.
But thank you very much again. I think it will be very, very helpful for many people because we don't really have this type of hands-on explanation. And many PhD students don't like to read. So
yeah.
So this type of hands-on thing can help many people. Once again, I really appreciate and thank you very much, Munir.
Yeah, thank you so much. Yeah, I hope that it will actually help many researchers like me, because it's just sharing the knowledge with each other. Yeah,
sure.
We want actually to create a very beautiful world that we actually sharing our knowledge, and we are trying to improve and develop ourselves. So
you are doing a wonderful job already, Munir. I already told you, look, I inspire from your research also, so I'm very grateful that you got some time out of your schedule and then shared your knowledge with a lot of people. I'm so grateful.
Thank you so much. Yeah.
Take care, my friend, and good luck for your future research.
Yeah, sure. Thank you so much, Dr. Faizan, and hope to meet you soon, maybe later.
Hopefully,
Okay.
yes.
Okay.
Take care.
Okay.
Goodbye.
Take care. Bye bye.